So in this video we're going to talk about measures of spread or measures of variation. And there's several definitions we want to talk about with this. The first one is range. And range, as I mentioned in an earlier video, sometimes goes along with mean, median, and mode. But range is simply the difference between the greatest and the smallest numbers in this set. So you do the highest number minus the lowest number to get your range. Then we're going to talk about quartiles. This may be a new term for you. And that's the values that divide data into 4 equal parts. So think about quarters, quart, 4 equal parts. Upper quartile, which we're also going to talk about as Q3, is the median of the upper half of a set of numbers. Lower quartile, which we'll also refer to as Q1, is the median of the lower half of a set of numbers. The interquartile range is the range of the middle half of the numbers. In other words, we're going to take that upper quartile that we just talked about and we're going to subtract the lower quartile. And the interquartile range we will refer to as the IQR. And then again, we're going to talk about that word outlier, but this time we actually have a formula that helps us find the outlier. An outlier is going to be a data item that's far apart from the rest of the data, and it has to be at least 1.5 times this IQR, and we're going to add it to our quartile 3, or we're going to subtract it from our quartile 1. So these are just some of our definitions. We've got one more coming up in just a minute. Okay, so then we've got a box and whisker plot, or sometimes we just call it a box plot. It looks like this, and they're commonly used to show a spread of data. Lots of things that go along with a box and whisker plot. So it looks like this. We've got our box in the middle and these 2 lines that come off the end that make our whiskers. There's 5 pieces of data that go with it. We have this part down here that's called our minimum, our lower extreme. Then this corner is our Q1, that quartile 1, or our lower quartile. The median, the middle, this Q3, the quartile 3, that's our upper quartile. And up here we have our maximum, our upper extreme. From here to here is our IQR, or that interquartile range. Here's our next definition. A box plot is a graph used to show groups of numerical data through their 5 number summaries. Their number summaries are the minimum, the Q1, the median, the Q3, and the maximum. A box plot divides the data into 4 equal parts. And here they are. Here's 1, 2, 3, and 4. And they're going to be equal, although it won't always look like it because sometimes the median will be way over here. But the number spread is actually equal. So this is what we call a box plot, or box and whisker plot. Okay, so let's make a box plot. So we're going to take these numbers, we're going to turn them into a box and whisker plot, or box plot. Okay, so first you have to find the median. Remember, to find the median, you have to put your numbers in order numerically. So if we put our numbers in order numerically and we start crossing off 10, 20, we're left with 13 and 14, right? So our median has to be in the middle of 13 and 14, which leaves us with 13.5, which I already wrote. So if our median is going to be 13.5, then we want to take all of this data, and that's going to be our lower half. So if you see step 2, it says to break the data into 2 equal halves. And then we want to find the median of both the lower half and the upper half. So here was my median. I'm going to take all this data, and it's going to become my lower half. Then all this data is going to become my upper half. Now I have to find the median of both of those. So my lower half was 10, 12, 12, and 13. The median of that is simply 12. My upper half was 14, 15, 16, and 20. The median of that is 15.5. All I've done is take all my numbers I started with, arrange them numerically, and break them in half. Now, this median of my lower half becomes that Q1, my quartile 1. Consequently, the median of my upper half becomes my Q3, my quartile 3. Okay, now, I need to identify my max and my min. This is very simple. My minimum is my lowest number. My maximum is my highest number. Super easy. So we've identified our 5 parts. Minimum, maximum, median, and then our quartile 1 and our quartile 3. So now I'm going to create a number line, which you know how to do, and I'm going to draw it on here. So I put my min right here. Put my max over here. Okay, I drew a line in the middle for my median. And remember, that goes at, my original median was at 13.5. Okay, My quartile 1 goes here at 12. And my quartile 3 goes here at 15.5. That's my box and whisker plot. And then from here to here represents my IQR, my interquartile range. My interquartile range I can find by taking this 15.5 and subtracting this 12. So I find that my interquartile range is 3.5. Okay, so let's do a little more. Let's talk about how we find out if we have an outlier. Okay, so we're going to use the same data we just used on the last slide. So first we have to find the interquartile range. Well, I've already told you. Q1 is 12 and Q3 is 15.5. We're going to subtract those, the interquartile range of 3.5. So that's step 1 of determining your outlier. Step 2 is to multiply that outlier by 1.5. So if we take 3.5, we multiply it by 1.5, we get 5.25. Okay, so now to determine the lowest extreme for our outlier, we're going to take that Q1, which if you remember our Q1 was 12, and we're going to subtract that 5.25 from it. So 12 minus 5.25, that leaves us with 6.75. To determine the upper extreme, take that Q3 and add our answer from step 2, or that 5.25 to it. So we take 15.5, or our Q3 from the last slide, add 5.25, we get 20.75. So now to find the outliers, we have to look and see, did our list of numbers have anything above 20.75 or below 6.75? Well, our min on the last one, our minimum was 10 and our maximum was 20. So no, we didn't have anything that touched this. So in this case, we had no outliers. So let's do another example where we look for outliers. Malfunction there. Okay, so here we have another set of data. So let's remember the steps. Find the median. If I cross these out, 2 and 12, 2 and 6, 3 and 6, 4 and 5. My median is 5. Okay, so now I take my data. Here's my lower half, 2, 2, 3, and 4. Here's my lower. Here's my upper. So this became my lower. This became my upper. So I'm determining an outlier without even making a box and whisker plot. Okay, so my quartile 1, remember, is the median of this half. Median of this half falls right here between 2 and 3. What's between 2 and 3? 2.5. My median of my upper half falls right here between 6 and 6. Well, the only thing between 6 and 6 is 6. So my quartile 3 is that. So next, in determining an outlier, I look for my IQR. Q3 minus Q1. So 6 minus 2.5 is 3.5. So my IQR this time is 3.5. Same as last time. So to figure out outliers, I do IQR times 1.5. So 3.5 times 1.5, I'm sure you remember, was 5.25. It is not always going to be 5.25, it just so worked out in these two problems. So now, take my Q1 minus 5.25, 2.5 minus 5.25. So this is going to be my lowest extreme. Take my Q3 plus 5.25, so 6 plus 5.25, this is my upper extreme. So I'm going back up here. Do I have anything this low? No. Do I have anything higher than this? Yes, I had this 12. So in this case, I did have an outlier. So do I have outliers? Yes. This 12 was an outlier because it is above my upper extreme. And that's box and whisker plots and outliers.